right, in this second video for Pythagorean theorem, we are still looking at a right triangle and using the Pythagorean theorem, and we're going to be finding the missing length of a leg. So we're looking for the leg instead of the hypotenuse. We're still going to use the same formula for Pythagorean theorem, a squared plus b squared is equal to c squared. And on this case, this example, we don't know this leg. And the other examples that we've looked at so far, we didn't know the hypotenuse. So label your two legs, label your two legs, and label your hypotenuse. And I'm just going to abbreviate hypotenuse here. Just leave it as that. And anyways, on here, we're going to substitute in our values. So a is missing, so we're just going to leave that as a squared. And our b is our other leg, which is the 4, and we're going to square that as well. And we have the hypotenuse, which is 5 squared. We'll go through and use the orders of operations once again. Parentheses, exponents, multiplication and division from left to right, addition, subtraction, whichever you encounter from left to right. And here I have 4 squared. 4 squared is the same as 4 times 4. I have 5 squared, which is the same as 5 times 5. And I'm just writing down my a squared. When I go through 4 times 4, it should be giving back 16. And 5 times 5 is 25. In order to solve for this, I have to realize that I have, this is addition on this side, but I need to get a squared, that's an a, squared by itself. And I need to move the 16. So when you're solving, you have to do the opposite. So here I had addition. In order to move it or get it away from this a squared, I have to do its opposite. So when we're solving it, we are subtracting. We're not going to subtract 25. If we did 25, we're left with nothing on this side of the equal sign. We're trying to get the a by itself, the a squared by itself. So we need to move this 16 to that side, but you can't just move it. You have to make sure it's like a balance. And if you had it, if you move it from one side, you have to do it to both sides. So on here, I'm going to subtract 16 from both sides. I'm left with a squared. Use your calculator again, and 25 take away 16. Punch that in. You should get back 9 for that answer. And when I take I'm trying to get a by itself. So when you undo a square, you have to square root that side, and the same to this. Square root of 9, or radical 9, is perfect square. So we're going to get back 3 for our answer. Our leg is equal to 3. So in here, I will type in a 3 shortly. I did want to point something out. In the previous video, I was looking for a 3, 4, 5 triangle. This happens to be a 3, 4, 5 triangle. Before I submit my answer, I am just going to switch colors here for a second. And on here, please notice that if you have a 3, 4, 5 triangle, and this is just a brief, quick summary of it, but you should recognize any 3, 4, 5 triangle is a right triangle. This is the leg, hypotenuse. If I took and doubled or tripled or quadrupled every one of those sides, the lengths of these sides of the triangle, they would all be right triangles. This right here, we have, this is a 3, this is what I'm trying to say, a 3, 4, 5 triangle. The hypotenuse is your longest side based on the sides of a triangle. Right here, if I took and doubled everything, this would be, if I multiplied everything by 2, as I'm saying, multiply that by 2, 8. Multiply that by 2, 10. A 6, 8, 10 is also a right triangle. If I took the initial, or even this one, but if I just take the first one and I triple it again, I doubled this one, I'll triple this next one. If I happen to have a 9, so multiply that by 3 to get to here, multiply this by 3, a 12, and multiply this by 3, I would have a 15. So these are all right triangles, and sometimes you can see it. I actually saw it before we started to work it all out, but I just wanted to point that out. So yes, a 3, 4, 5, a 6, 8, 10, a 9, 12, 15. Those are all right triangles. Anyways, back to this problem, just to try to finish this part off. I'm typing in over here a 3, and that should be the answer. So when you're going through these problems, yes, you might encounter some that have decimals. You might have things of that nature. But this right here is showing, and we'll go through another one or two, but on here it's showing that you're looking for the leg, and you may have to apply it to decimals as well, or round your answer. But don't make a silly mistake. Make sure you read directions. What is the length of the missing leg? We've solved it. We got 3. It's 3 meters. We don't have to type in meters here. It's just the number 3 because it already has meters labeled. All right, submit, and it's good. All right, keep going. We're going to go to the next problem. I'm going to pause it for a second and see if I find a specific one that I want to go through. All right, I skipped ahead to this next problem. Again, look and notice what you're trying to solve for. Pythagorean theorem, I'm highlighting that. Missing length of leg. So a leg, and we're going to solve for the leg of it. It does tell us in the directions what is the length of the missing leg, if necessary, round. So expect that we're not going to have a perfect square that's just going to come out to be just a nice whole number. We're going to actually have to probably round, would be my guess, to the nearest tenth. So we'll look at that in a second. All right, so when we're going through this problem, same setup. Label always where your legs are and where your hypotenuse is of the right triangle. Only apply this if you have the Pythagorean theorem, that is, if you have that symbol or it states in the directions in the given right triangle. So go through, and again, same thing, a squared, same formula, and you have to memorize that. A squared plus b squared is equal to c squared. All right. Okay, so it would apply to any kind of real world problem as well out there. A lot of times they use some sort of, it could be the pole on a sailboat, could be a mountain, and you're trying to come up with the height of something, if you know a certain angle, possibly, if you know, we get into further details, but they would give you 2 lengths for Pythagorean theorem. They wouldn't give you an angle. As you get further into math, you'll learn some different trig kind of formulas. But right now, we are looking at leg here, and leg over here. We have a hypotenuse as well. Hypotenuse is over here. Okay. And just abbreviated right there. All right. Go ahead and substitute in your values and try to solve. All right. So yes, your A stays the same. Your 5 will go in for a leg, and this is a leg here, the B. A and B are legs. And then you have the hypotenuse followed in here where the C is, and substitute the 7 in and square it. You want to solve this. So take a look at it and think about what you have to do in order to solve it. All right, I know that I have to get A by itself. I know what 5 squared is. And don't you? All right, so take a look at it and punch it in onto your calculator. What is 5 times 5? Yes, it is going to give you 25. And over here, 7 times 7. 7 squared is how much? It's not 14, so don't write down 14. Yes, 49. 49 is the right answer. We're trying to get A by itself, A squared by itself. So we want to move this to the other side. Keep 49 where it is and get the 25 moved. In order to move it from this side, you do its opposite. It's add over here, 25, so we're going to subtract it. And then 25 and a minus 25 gives you back 0 on that side. And so that's how we're moving it. The one side will give you 0. Okay, so that part adds up to 0. This part here, we're going to add this positive and negative number, or looking at that, same as subtracting. So 9 and 5 is a 4. I'm adding a positive and a negative, basically, or I'm subtracting them. 49 take away 2 is 2. I get 24 for my answer currently. That is not the answer I substitute in. On here, though, we have to realize that it's not a perfect square. We're going to square root this side, and we will square root that side. So anyways, I will have A is equal to, it says round to the nearest tenth. So punch that number into your calculator and round your answer. So go ahead and do that. Okay, so what did you get for your answer? Hopefully that was enough time. Okay, if you need to pause it, pause it. Otherwise, I will continue with this one just so you have a rounded to the nearest tenth problem, and then you can finish the rest of the problems in this section. You should be getting an 80 to a 100% to be successful, and I'll write that in the directions back on the Google Doc. All right. So I have for my answer 4.89, 8, 9, 7, 9, 4, 8, 6. And on here, that is approximately equal to 4 point, here is my tenths. I'm looking at the number that's next to it, and it's obviously higher than a 5, so that's going to bump the 10th spot up by 1. So that brings it to a 4.9. 4.9 is the answer that I'm getting back. Let me substitute that in, and then you can continue on with the rest of the problems in this section. Okay, it's good.